it's recording. So I'm recording the screen here. Here we go. 5.2 in year 12 and in your textbook 10.4, types of data. You need to be able to tell the difference between each type of data. What types of data? So when you collect information from people, there are different ways you collect the type of data. One is called numerical, which is the one that you're probably more familiar with and probably use more often. And then the second one, starting with C, hands up if you know this one. Jack? Categorical. So you got numerical versus categorical. One way of thinking about it is numerical is represented by quantities, numbers. So it can be something that is measured or counted, which I wrote down here. So it can be counted or measured, which is why I split up into two different ones. Versus categorical, usually I think of it as labels. Okay. So anything that has a label, a name to it, like your brand of cars that you like, or the house companies or real estate companies that you sign up to so they can sell your house or buy your house, or you can buy houses from. Those are names. Yeah, schools, those are names. So Viewbank College versus St. Helena or Baldwin High, those are names. So it's under categorical. So hair color is one. You can have size, postcodes. What is a G? What was I thinking of? Hair color. I don't know. Maybe grades. Maybe that's what I was thinking. Let's fill it in. Grades is one. Okay, so you're getting A plus or a B, B plus. Those are grades. So it's a label. Versus numerical, you can talk about height. You can talk about weight. You can talk about time. You can talk about number of siblings. Something that you can count or measure. But we break it up into two different values, and there's a reason why it's broken up into two, which that's what you will need to be able to explain if you're doing the exams next year. They will be testing why do you need to know the two, and which graphs do you use for specifically a discrete data. So which graphs do you use? Do you use a dot plot, stem and leaf? Do you use histogram? Do you use a bar graph, pie chart? Why do you do it for discrete and say you don't do it for continuous? You have to be able to explain it. That's the difference. Okay. So we have discrete versus continuous. One way to remember the two, discrete, sounds like it's very separated. So what are things that are separated? Shoe sizes. So your shoe size, it's 10, 10 and a half, 11 or 7, and then 7.5, and then 8. But you never go into a shoe store and say, can I get 7 and 3.2 as my shoe size? Doesn't happen. Whereas weight, see continuous, there's a whole spectrum of possibilities. See, weight, you could be, 49.12 if you want to be very exact to 2 decimal places, or you could be 1 decimal point away, so 42.1, 42.3. So everyone here could be slightly different. And when we went further and further in terms of number of decimal places, it can be infinite possibilities. That's why it's continuous. And that's what we call measured. So what are things can you measure? Your height, your weight, your temperature, speed. What else is there? I don't know. Anything that you think that you can measure, that's what we call continuous. So it's not discrete. Whereas if I said number of siblings, if I asked you how many brothers and sisters you have, you would either say 1, 2, sometimes you may say half, but it's very, half is in like a half sibling. Yeah.
Oh, okay.
Yeah. But it's very, yeah, it's very segregated. So that's discrete. Okay, so that's how you tell the difference between the two. One's counted, one's measured. Then we look at categorical. Nominal versus, what's the second one? Hands up if you know. Liam. Ordinal. Ordinal. Ordinal, which the ORD kind of reminds order. So it means there's a ranking. So remember, it has to be a label, but this label has to have a ranking. So you actually put them in a particular order. So for example, small, medium, large, you wouldn't write MSL. Like you would find that already strange if you walked into Costco and went to buy the aisle for t-shirts and then put it in MSL. You'll be actually expecting that it's small, medium, large because you expected order. That's called ordinal. So it's labeled, but it has an order to it or ranking. Okay, so small, medium, large versus nominal, which I think of it as name. So it doesn't matter. No order. So here you can say no order. So what's an example of something that has no order? Name of schools. Name of the makeup brand that you buy doesn't have an order to it. What else doesn't it? The car brands doesn't have an order to it. The t-shirts or clothing brands you like has no order to it. It's just a name. In fact, your names in this classroom is nominal. Okay, so there's no ranking per se for your names. Ordinal will have to have something. Okay, that's a difference between the two. Now, what type of graphs fall under which? That's later I'll explain, but it's actually I already kind of organized it for you. For those who want to do exams, this is what you must know. Pro tip. If the number is being used as a label, so the data that you're looking at, if it's like 5, 10, 20, whatever it is, and it represents labels, the number of people who like Maybelline, the number of people who like, I don't actually know all the makeup brands, so I'm going to go to something else. Let's say schools. How many people go to Viewbank College versus how many people go to Baldwin High or Uni High or Melbourne High? Then that number, if it represents a school, so it's a label, the data is categorical. But when it's categorical, you have these options. Bar charts. I'm highlighting bar charts specifically for a reason. You could use pie charts as well, but bar charts. Why am I highlighting bar charts? Because students think bar charts and histograms are the same. That's one of the most misconceptions in the exams. So if you think of next year for exams, they're two very different graphs. They look the same, but they're different. Anyone know the difference between a bar chart and histogram? Ooh, it's actually the other way around. Yes, and that's the reason why, and if you think about it, why is one separated and why is one not separated? Why don't they have gaps? See, labels, whether, let's say if I put your names on a graph, so if I said I had here Michael, then I had Mitchell, so M-I, then I had Jack, okay? It makes sense that the bars are separated, yeah? Because you guys are individuals. There's no linkage between you two. But if I talked about weight, which is now number, so measured or countable, or counted, just write count. If the data is numerical, it has to have some measurement. It's continuous, right? So if I asked you now for your weight, then it makes sense that when you're talking about from 140, also I'm thinking of pounds right now, so let's go kilograms. So let's go 50 kilograms to 100 kilograms. There is a continuum. That's why where you're sitting at, how many people sit between, say, 50 to 60, as an example, that is connected to the next person who's from 60 to 70 could be like that. That's why they're connected. And that's what histograms represent. Histograms have to represent a continuum, whereas this one doesn't. That's why bar graph specifically is for categorical. And I promise you in the exams, those are the two most common type questions. That's what they chuck in because they want to know if you understand what the difference between the nuances between them. Okay. So this one usually links to frequency and you can then do like frequency polygons. That's where year 12 stuff, which we'll talk about later. But that's a pro tip there. So those who want to do exams for next year, put like a star around there. That's 1 for 5.2. If you had to take something out of 5.2, this is pretty much what they want you to know. Okay. All right. So couple other things. So these ones all countable. Think about dot plots. If you remember dot plots, they're all dots, kind of like that. It's all countable. So it should remind you it's numerical. So hence numerical data. Same with stem and leaf plot. It's all numbers left on right. Histograms, I explained that continue on the x-axis. And box plots, again, it's a measurement. You can't do measurements of labels. Doesn't make sense. Okay? It's like saying find the mean of you guys. You know how we say mean is add all the numbers together and then divide them by the numbers? It doesn't make sense if I added, Mitchell, I added Michael, I added Jack, and I added Archie, and I divided by 4. What does that mean? Doesn't actually give me anything. Even if I gave them a number, if I said you're 1, you're 2, you're 3, you're 4, and I added them, 1 plus 2 plus 3 plus 4, and I divide them by 4, what does that number represent? Doesn't make sense because that number was a label. Because 1 represented Michael, 2 represented Mitchell, then that doesn't make sense if I did the average, even if I use the formula. So that's why it matters. What does the data represent? Is it a label or is it a number? Because a number tells us something. You can add all the numbers together and whatever the mean is or the average is, it tells us something. But if I added labels, it doesn't make sense. Okay? So that's where at a year 12 level, you have to know the difference between the two. At year 11, what do you have to do? This is what you have to do. Your exercise to pass or at least get an S for 5.2 is to be able to do this. I give you a bunch of possible data and you tell me, is it categorical? Is it numerical? Is it ordinal, discrete, continuous, or what's the other one? Nominal. Okay? Let's start off with this one. Let's see if you understand it. Favorite sport. I just want to know, is it categorical or is it numerical? Let's start off with Michael. Categorical, very good. I'm going to put a C because I'm too lazy to write categorical. So C for categorical, very good. That's correct. Let's go next one. Mitchell. Type of transport to school. Categorical, because you can take a bus, you can walk, you can take a train, car. Those are labels, not a number. C, let's go with, on this side, let's go with Kate. Number siblings, what would this be? Numerical, because it's a number. If I asked you how many brothers you have, you'd give me a number. You won't give me a name. Next one, D, customer ID number. Who wants to have a go with this one? That's the common mistake. Why is it not numerical? It's a label. Think about your, your user ID. That number doesn't mean anything. Well, it can to some degree, but there is no particular, if anything, customer ID number could be categorical, but ordinal because there's an order to it. Okay, so this is one of the most common ones. Most students think it's numerical. Remember, if I added these IDs together and I found the mean, what does it mean? If it doesn't really mean anything to you, it doesn't make sense, then there's something wrong with the data. Yeah, mean is one of the best ways to kind of decipher, is that data something that you can use or something you can't. So customer ID actually, as a trick, oh sorry, not N, it's C, categorical. What about age? What is age, Archie? Numerical. Age is numerical. It is it's a number that you can actually work out the mean age. That makes sense. What about F? Jersey numbers of AFL players. Jack. Categorical again. You're picking up on the idea. Yes, they are numbers, but they're jersey numbers. What do they mean? Even if I added the numbers on the jerseys together and found the average, it doesn't mean anything. It doesn't make sense. So hence that's categorical. Okay, so sometimes these categoricals use numbers, but the numbers is a label. It's categorical. What about G? Can I please have, let's go with Olivia. Test scores out of 100. Numerical. Because those numbers will have a mean. It has an average. Makes sense. So therefore it's numerical. And then H, mobile phone numbers of students. Let's go with Georgia. Categorical. Your numbers is a label. It's just a setting to get to a certain place. It's like your number plates. They use numbers, but they mean nothing if you found the average. Just think of it that way. If you added all the numbers together and divided by numbers, it doesn't mean anything. So that's why it's categorical. It's a label. Okay? Well done. That there is pretty much year 11. That's all you need to know. Yeah, so at the Y stage, that's year 12. Year 12 will give you questions to explain, to interpret a graph, to find out what's wrong with the graph. That's year 12. Yeah, year 11 is just literally being able to state the difference. So we've done categorical versus numerical. Let's go to now ordinal versus nominal. So we know all of these are categorical. Every one of them is categorical. But which one is it? Does it have order or doesn't it have order? Okay, so welcome. You can grab one of these sheets. Anywhere's good. Here you go. All right, so we all know it's categorical. Let's go eye color. Is it ordinal or nominal? Remember, ordinal means order. Nominal is a name only. So eye color is nominal. It's just a label. N for not. I'm going to do NO so you don't confuse with numerical up there. So NO for nominal. Finishing position in a race. So you can be first, second, or third. Gold, silver, or bronze. Ishara. Ordinal. Ordinal because obviously it has an order. Let's go with C. Year level at school. Year 12, year 11, year 10. What do you think that is? Let's go with Michael. Ordinal. Yes, that's correct. It has an order to it. 7, 8, 9. Even though it's a label, but there is a ranking to it. Car registration number. What would that be? Let's go with Estella. Nominal. Very good. Again, there is no particular order. Unless you... Yeah, actually, I don't know. No, there shouldn't be. Yeah, the letters all generally random, so there is no order to it. Survey agreement scales. Meaning, on your survey, they call it a 5-point scale or a 7-point scale, where you can be like neutral, agree, or disagree. That's a 3-point scale. 5-point scale would be like neutral, agree, strongly agree, and then on the other end, it's like disagree and then strongly disagree. That's 5-point scale, and then you can go to 7-point scale as well. But that's what a survey agreement scale is. What is that? Nominal or ordinal? Let's go with Mitchell. Not nominal, because there is an order on your scale. They usually write strongly agree, to neutral, to disagree, to strongly disagree. There is a particular order to it, so that's why we call it ordinal. Okay, so yes, they're labels, but these labels, you never see a survey where I mix all that around. Yeah, you don't see strongly disagree in the center and then suddenly neutral on the very other end. It has a scale to it. Okay. Last one, house numbers on a street. Ishara. Yes, that's right. Pretty good. House numbers on a street is ordinal. There's an order to it. All right, so that, if you're looking at that and you're feeling pretty confident, that's pretty much what Chapter 11 is. I don't think I did a discrete continuous. I did, but I shortened it because otherwise we're just doing so much practice here. But hopefully by this point you've got an idea of what you need to know at a year 11 level basic is to know the difference between the data. The Y component is where it's year 12. Okay? So here we go. For year 11s, you can fill this in yourself. Age and shoe size. You should be able to tell the difference between the two. I'm just going to write the answer so you can see if you've got it right. So state whether its data is discrete or continuous. Age is continuous because you can be 3 years and 2 months old or 3 months old. You can count to months and days. Shoe size is discrete because you can never buy a shoe size that is 10.125. It's either 10, 10.5, or 11. Yeah? All right. And then from here, it's pretty much year 12. Okay, so from here, if you're interested in seeing what it's like at a year 12, that's 5.2 question 9 from the year 12 textbook. What are they getting you to do? So here's a graph. Notice it's a bar chart. Okay, why is it a bar chart? Because they're not touching. Very good. But look at the data. Hot, warm, mild, cool. What type of data is that? Categorical. What type of categorical? Ordinal, because there's an order to it. It went from cool to hot. So there's an order to it. So it's ordinal data. That's why we use a bar chart. And that's the kind of thing when they say describe the data in this example at a year 12 level, that's what you need to be able to say. You have to demonstrate to examiners that you actually understand what this represents. Okay, rather than just looking at a graph, we can understand, oh yeah, that's categorical data there, but technically it's ordinal, and we use a bar chart, not a histogram. They're all separated, and we can count the frequency. So in January, number of days in January that was warm, looks like we got 15. 15 days it was warm, and then 8 days was hot, 5 days was mild, and 3 days was cool. Some of the questions could be like, so how many days were there in January? Counted there. Then you can add all the numbers together. They might say, find the, what's the mode? What's the most popular or most common temperature in January? Those are the kind of questions you can expect at a year 12. Yeah, so that's a problem solving, reading, interpreting. That's what they want at year 12. So this is what they want at year 12 that I've highlighted. So although in VC Foundation exams, it is not asked directly. So they don't go, is this categorical? Is this nominal? No, that's year 11. That's year 11 content. Year 12 content does it indirectly. From this, when I ask you to describe it, I will learn if you know what a nominal, ordinal, categorical data is and why you use it. That's year 12. So they want to know that. Do you know how to choose the correct graph? Do you know how to interpret the graph? Can you justify the representation? Could you use a pie chart instead as an example? And then why? What's the difference between the two? Avoid invalid calculations. So for example, finding a mean or something. Sometimes it doesn't make sense to find mean of categorical. Actually, all the time, it doesn't make sense to find the mean of a categorical data. So do you know when to avoid? That's what they'll be testing. Why does that happen? It's because students do not know when to use a graph. They just think a graph is a graph. Students don't know how to read information because they're not looking for details. One of the exercises in year 12 and year 11 is called misinterpretation of data. You're going to learn to look at how do people out there in the real world actually use graphs and data to skew your opinions. That's what they do in polls. That's what they do in the news and media. They give you specific graphs and they do it in a particular scale so that it actually makes it look bad or good or in favor of what they want to sell to you. Your ability to interpret that is the year 12 content. Year 11 doesn't need to know that. You just need to know how to do. Yeah? You normally lose marks on explanation as well. So students, they think maths is just numbers. No, maths is critical thinking. Critical thinking means you can explain to people why this is the best decision. So most times they don't write their answers with explanations. And a lot of times, especially year 12, we ask you guys to interpret. Hence, explain. All right, so those are the 3 most common reasons why students find the year 12 foundation exams hard, why the average is 26% at the moment, which also means you guys have a really good chance if you practice this for the next year, you should at least beat the average of 26%. All right, here's a sample exam style question. A class collects data on the postcodes where students live. So think about postcodes. We're in 3084 for ViewBank. State whether this data is categorical or numerical. Which one is this one? Let's go with Olivia. Postcode. So if I'm collecting data on postcode, so 3084.
Numerical.
Ooh, which one is it? N versus C. Which one? Let's go a poll in this class. Hands up for N. Hands up for numerical. I love how you're all looking at each other to get confirmations, like, because if we all get it wrong, we get it all wrong together. You know, it's like one for all, one for one.
It says on the other side in the thing, categorical, this represents qualities, factors, example, hair color, grade, size, postcode.
Very good. I did chuck it in there to see how many of you actually read my notes. It is categorical. Again, think about it. If I asked you to find the mean of the numbers, if you added 3084 and, I don't know, 1234, if you added all those and found an average to it, what does it mean? If it actually means something to you, you can actually explain it to me, then it will be numerical. But if you can't explain to me what those numbers mean, it's very likely it's a label. And that's what it is. I mean, 3084. Why is this 3084? I don't even know why it starts with 30. I'm sure there was a reason why they started with 30. But it's a label. It's a name. Right? Just like your names has been chosen. Your parents might have chosen because it has a meaning to it. Or they like the sound of it. There was a reason why they chose it. But it's a label at the end of the day. Yeah? So yes, it is categorical. And I love postcodes because we see numbers all the time. And then you likely think numerical means numbers. That's why they do it. Typical exam question, postcodes. So yes, it's numerical. Let's try another one. Name the most appropriate graph to display this data. So now I'm asking you to think categorical. What's an appropriate graph? Bar charts, one of the best ones to use. Bar charts because you have more options. Pie charts can work if you just want to see a quick summary in one space. You want to see like how much portion it takes in. Usually you do that for shares. Pie charts are great for shares, you know, like, or looking at your overall gender group in this class, for example, like males versus females, you can see more. That's what you would use it for. Explain why a histogram would not be appropriate. So now you may know it's a bar chart, but can you explain to me why a histogram is not appropriate? Who wants to have a go to explain? So that's the third skill. You understand how to label or identify. You can interpret or choose the correct graph, but can you explain to me? Who wants to have a go with explaining? Because that's one of the harder skills. Jack.
As the postcodes aren't on continuous weight, they just go 3084,
Yeah, that's very good. That's a great explanation. So even though you got an inkling of what it is, it's how you explain it. You see, you're right. Histogram has to be continuous. Doesn't make sense if I go from 3084 and the next one's 3085. Can I have 3084.5 as a postcode? No. So as soon as you say that explanation, see if I said that to you, see how good I'm explaining it to you? So when you write it on the sheet for the SAC or for the exam, that's what examiners are looking for because you're explaining. Even though you kind of understood it before, but how many of you actually were able to explain it to a point to show the difference why histogram's not appropriate because that is a continuous x-axis versus bar chart, it's separated. Yeah? All right. That's an example for next year. That's not what year 11s are doing. Year 11s literally go back to the very first page. Your skill is to do this. Okay, so at a year 11 level, if you just wanted to get an S, this is what you did from year 7 to 10. It's all theoretical. You're not really applying. But can you see the next bit? It's actually about applying. It's like, why do we do it? And if you're a statistician, which they get paid a lot to do, that's what you have to decipher. You have to know what you're projecting, and then you have to explain it to your shareholders. And that's when they're like, oh, great work, great presentation, and then you get promoted, that kind of thing. So your ability to explain, interpret, that's what the real world uses. Just getting an S, that's all you need. There's no difference between the two. Cool? All right, that was me explaining for about 30-ish minutes. So I'm going to stop, and I'm going to stop the video.